Hey everybody, and welcome to this IKinema tutorial. My name is Charlie, and in this lesson we will cover marker solving. Let's take a look at our scene. As you can see, we have a T-pose skeleton and there are several locators surrounding it which act as our markers received from the motion capture data. When I click play on the timeline, we can see the markers moving around the scene. Our goal is to assign each joint on the skeleton to a marker in the scene using IKinema. This will allow the joints on the skeleton to move alongside our markers in a believable motion. So let's begin. First let's find our IKinema menu. If you can't see it at the top, make sure you're in the animation menu set, and you can check by looking on the drop down menu on the left. Select IKinema and tear off the menu by selecting the ribbon at the top. This way we can access the features quicker. Alright, let's go ahead and create our IKinema solver. Select the hips and shift select any joints we don't want included in the solver. In this lesson we won't include the fingers or the thumbs as they often require a more complex setup. Once we have selected our joints, click Create IKinema Solver. If a warning like this appears, just press Yes. This normally appears if we have had an IKinema solver on the joints before, but have since deleted it. Now once the solver has been created, turn off the option in the IKinema menu that says Toggle IKinema on Selection. This will prevent any joints from shifting about while we are setting up our markers. Okay, great. Let's take a look at the attributes that the solver created. We'll need to prepare a few values before we start assigning markers. First, make sure the continuous solving option is turned off. This option is really good when we want to export or bake our animation, so we don't want it turned on just yet because it can cause some issues while we are setting up our solver. The other setting we need to change is the P coefficient. This setting is basically the overall gain of our solver, and a good value to start off with is about 0.2. Now we can start assigning joints to our markers. To do this we will be using IKinema tasks. The task we will be using is the position task with offset. This task in particular allows us to manipulate an area on our solver keeping in mind the position of the marker compared to the position of the joint. Alright, let's start off with the hips. First select the hips, then shift select a marker which is close to it. Then click Create Position Task with Offset in the IKinema menu. And that's all there is to it really. What we need to do is keep doing this for each marker in our scene. And keep in mind that we can actually assign more than one marker to a joint. We will need to do this as we seem to have quite a few surrounding our hips and other areas of our skeleton like the head. So let's go ahead and do this for each marker. To speed up the process we can use the G hotkey to carry out our last operation. Okay, great, we're going to do this for each marker and I'll speed up the video until we've assigned each one. Alright, we've almost set up our markers. If at any point you think you've assigned a marker to the wrong joint, you can always delete the task by selecting the black line that connects it, and just press delete. Then you can go ahead and create the task again. Also, like I said before, we have markers for the fingers, but this requires a more complex setup, so we won't cover them in this lesson. Okay, now that we have created the task for our markers, let's turn on the IKinema solver by selecting the hips and turning on Toggle IKinema on Selection. Now let's see what we have when we press play on the timeline. Alright, it's looking okay, but not every scene you work with will end up looking okay straight away. So let's go through some of the attributes we can configure to achieve a better result. The first thing we can do is address the stiffness in the spine. One way is by selecting the joint and finding the Enable Limits option in the IKinema segment attributes, and turning it on. This basically restricts the movement of the joint, which you can configure more by altering these values here, but the default values are fine. Another way is by increasing Maya's built-in stiffness value found a bit lower down, but as we have already enabled the IKinema limits, it isn't necessary. Next, let's take a look at the global IKinema solver. We can see it if we have any joint selected. Just switch to the tab that says IKNM Solver Instance 1. Alright, so let's look at the max iterations value. This lets you change how accurate your solver is going to be. The higher the value, the more accurate your joint's positions will be, but requires more performance from your CPU. The lower the value, the more misplacements you will get with your joints, so it's best to try and find a good balance when changing this attribute. I think for this scene around 500 is good. Alright, the next attribute we can use to improve our solve is the P coefficient. Like I mentioned before, this attribute is our overall gain for the solver. Much like the max iterations, it's important to get a good balance for this attribute. If the value is too low, the joints will not keep up with the tasks we have assigned for each marker, but if the attribute is too high, we're going to experience some unstable results from our solver. I think for this solver, about 0.15 is a good value. Now is a good time to see the effects of the continuous solving option. If we turn it on, the position of the joints in our solver are calculated based on their position in the adjacent frames. This produces smoother animation, which is why it's good to enable this option when exporting or baking the animation. But it's not a good idea to have this enabled while we are still working on setting things up, because as you can see, if we start jumping around our timeline skipping frames, we will see some strange results coming from our solver. To fix this, just turn the setting off again and it will look normal. Okay, great, that's all we need to do to cover marker solving. Let's click play to see how it goes. And that concludes the lesson, so thank you for watching.